Hello, this is Trevor Thomas, presenting my students' result prediction project. This is part 5. The contents of the presentation, we shall first start with the introduction, dataset description, the heat maps, the correlation matrices, the box plots, feature independence plots, outlier plots, illustration of patterns of interest, illustration of trends in time and space, and the references. We'll start with the introduction. Mainly in this section, we're going to carry out exploratory data analysis, where we get to visualize the different parts of our data set in order to discover patterns and analyze them and visualize them accordingly. That's what we're going to look at today. The dataset description. The dataset is got from the UCI machine learning repository. It's got from a secondary school. It comprises of 649 instances of students with 33 attributes. And attributes include the student's grade, the demographic, social, and school-related features. And it was collected using school reports and questionnaires. The target attribute is the final mark, which is G3 in the dataset. The heat maps. So we'll start with the heat maps. What a heat map does mainly, it can be used to display the coefficients with the main objective of visualizing and analyzing the strength of correlation among variables in the dataset. For this case, our target attribute should be focused on the most, which is G3 here. So we get to see here from this, the magnitude of the correlations according to the color that is assigned to it. It moves from cool to warm. So the closer the color is to red, the higher the magnitude of the correlation. From here, we get to see that the attributes G1 and G2, which are the previous tests that a student has, have a higher correlation compared to the other features. For example, the failures. Then we also look at this is the conclusion that we have got from the heat maps. We get to see that G1 and G2 have a very strong correlation, as I said before. Unlike other attributes, for example, health of the student. Health of the student is somewhere here. And we have to find the relationship. The fact that it is closer to blue makes it have a very weak correlation with the target attribute, which is G3. Then we look at the correlation matrices. Actually, to get the heat maps, we actually have to first get the correlation matrices. The correlation matrix is simply a table that shows the correlation coefficients between variables. It's similar to the heat map, but without the color. It's simply a table, and it has a bit more detail because there are more nicer figures. It's a bit more structured. It's looks less of a drawing compared to the heat map. Yeah, it's just a table. So from the table, we get to see the same conclusion as we made with the heat map. We get to the G1 and G2 have a stronger correlation with the target attribute, which is G3. Yeah. So box plots. The box plots can be used mainly for comparison visualizations on the components of a data set. Box plots are typically used to compare categorical variables with continuous variables. Categorical variables refer to those kind of variables which have finite values. For example, boy, girl, it has only two values, either boy or girl. While continuous variables are those that have continuous data, like numeric data. For example, like when you're getting temperature, that's a very continuous variable because it does not have a finite number of values. This is a box plot. With this box plot, we are using our categorical value for this box plot. We will be using study time, because study time is a categorical value which ranges from numbers 1 to 4 according to the amount of time someone has taken to study, and we are mapping it with we're relating it with the target attribute, which is G3, and we get to see from here, this line here refers to the median. We get to see that the median, we're going to see that the higher someone studies, like the higher the number of someone's study time, the higher the value that corresponds to someone's study time, the higher the median of the scores someone gets. And we get to see here that for 3 and 4, someone has the higher median. They actually look the same, but for these values, which are less, the less someone studies, the less the median of the marks someone gets. That's how box plots can be used. We also have here feature independence plots. So the feature independence plots can be used to analyze behaviors of values of distinct features of a data set. For me to make these plots, I had a lot of interest in the G1 and G2 since I realized they had so much, they were quite very strong in terms of correlation with the target attribute. So I drew a histogram, I put a histogram of G1 and G2. And I also added on absences because it's actually one of the features that I'm going to use for the project. And also a continuous variable. So I got to see here with a histogram, I'm able to tell which values are the most frequent under that attribute or column that I'm using. Here we get to see that the values with the highest frequency range between 10 and 15, while for G2, the values the highest frequency don't go beyond 10. And while here in absences, people's absences do not go beyond 20. The most people go is roughly 10. That is the highest value in the absences. So with such a feature, we're able to tell the frequency and the patterns, the behavior of a certain column in terms of its values. So outlier plots, an outlier refers to values that lie in the extremes of data. I used a scatter plot in order to identify any outliers. So from this scatter plot, I used absences on the x-axis, and I used the G3 on the y-axis because it is the target attribute. So I got to see that there's an outlier here. As you can see, this point here is actually at the extreme point of the data, as you can see from there, compared to these other values here, which are actually clustered at the end here, but the rest are actually at the extreme points. That's what I would call an outlier. Then the illustration of patterns of interests. I would start with the target attribute. Of course, that's the G3. I drew a histogram of the target attribute, and I was able to tell that the values, the most frequent values, lie between 10.0 and 12.5 for the target attribute. I also drew scatter plots using G1 and G2 because I was so interested in in the patterns that I got to discover from the heat map, all the previous plots that I had made before. And I made a scatter plot with the target attribute G3. And I got to see that this is a regression problem because you can see here there's a relationship between G2 and G3 and G1 and G3 is a relationship there, and it shows so clear from the scatter plot. Illustration of trends in time and space. These kind of plots deal with time-related issues whereby you can relate a certain attribute and get to see how it changes as time goes on. You can relate to the time attribute. Unfortunately, in my data set, I do not have a time-related attribute like time, date. I do not have such an attribute. Therefore, I could not be able to make an illustration about the trends in the time and space. But yeah, the good thing is I utilized the rest of the abilities of my dataset, and I got to do other work that I got to do. For example, I was able to get the scatter plots. The most interesting thing for me as I was doing this work was the heat maps, because I realized the fact that most of my data was numerical. I was able to plot and make a heat map for all the attributes and be able to get to see all these different correlations and get to see how they change and I get to see how they relate to the target attribute. Thank you. And my references, most of them I got from the Cargo website, as you can see here. Thank you for your time.